Muy buenos días, este es el primer video sobre el proyecto del estimulador neuronal. En esta etapa del proyecto lo que voy a presentar es la comunicación USB a través de la computadora hacia el USB y la implementación de un automata de estados. Este video lo voy a repetir en inglés porque es para un amigo y sí, el proyecto tiene que ser en inglés. So then again, first of all, regards to Vittorio, my partner in this project. So what we are going to do here is to implement USB communication from the computer to the debugging board PIC32 and then prove a automaton of states for a neural stimulator. Without going into a lot of detail, what we need to do is output a signal from the microcontroller, which we will control from the computer. What we want is to drive a current, not a voltage, but from the conversion from voltage to current won't be discussed right now. What is important for us is the time intervals. As we can see, we have 1, 2, 3, 4 intervals between each stimulation. So a way to tackle this problem is through state machines. It's really efficient. So without going into further detail, I'm just going to prove this. First of all, let's go to MPLab, debug main project. Nice. Okay, so the program is now loaded into our PIC. We can see 2 USB ports. This is just for programming and this is the communication. Actually, if I detach this side, the program still runs. So and now the blinking LEDs is waiting for communication. Pretty much is the first state of the machine. So we go back to our computer and now I'm going to show the graphic user interface made on Visual Studio. It's quite simple. Let's just run it. So what we have here is a set of values that we can configure. As I told, right now the only ones important are the time. That is the cathodic pulse duration, the interpulse interval, blah blah blah. So the other values don't even care. And also it's not in microseconds or microamperes. It's going to be in the order of milliseconds, because if not, we wouldn't be able to see it. So we connect. Enable port connected. Yay, that's good. Okay. So the amplitude is not relevant. Don't care mind about that. So cathodic pulse duration is the first value. I'm going to label it as 4,000 milliseconds. Interpulse interval, that is the second, 3,000. The amplitude, then again, is not important. Anodic pulse duration, 432. And interstimuli. The number of electrodes, that's going to be controlled in the hardware. It's not important right now, so just 1 and 1. So we send information and we go back here. So for each state we are going to see the duration. This is 3, 2, 1, change, 2, 1, change, 1, change. So that's sort of the 4 states. I know it's funny. Whenever I need to explain to my family what I'm doing, they are like, oh, blinking LEDs, wow, cool thing. But of course, between these intervals we will be able to do more stuff, which I cannot prove in this debugging board. I should have picked something bigger. So the other function that we have, because it's important, it's a stop button. But this only works until the very end of the cycle. So until the 4th state, we are going to see how the stop works. Stopping gets us back to the waiting for data to arrive. So we can now change these values just to prove that I'm controlling this from the computer. Let's set everything to 1 second. this goes to 1, this goes to 1. So send that, and 1, 1, 1, 1. Yeah, also something important is that right now the delays are implemented in just a cycle of knobs. I need to still fix that. I'm going to be working with the interrupts, which is more smart, and I need to still clean my code and a lot of other things, but so far this is the proof of concept. Next step is to do the PCB with the digital to analog converter and the current driver and blah blah blah. But yeah, I will upload some video of this. So thanks a lot for your attention. Regards to Vittorio and also to Aldo and Campos, who will see me from Mexico. Ciao.